I'm sorry. I was just rocking out to a little AC/DC there. So, oh, speaking of AC/DC, maybe we should have a little conversation about that. So this little video lesson, we're going to get into AC/DC currents and what they are. Okay, so in our world, we basically have two different types of currents we use to power our world. Okay, AC and DC. AC stands for alternating current. DC stands for direct current. Okay, now alternating current is the dominant way we send power across our entire country. And the way we do that is we alternate the polarity between the current. So we shift which direction we're sending the electricity to a device. Now, let me jump out of our slideshow here and kind of show you what I mean by that. So if you could imagine the power plant, again, this is using a water analogy, so we're not actually pumping water to our houses. But if you can imagine, the power plant actually sends the power one direction to your house or the other direction to your house, and it actually alternates back and forth, back and forth, back and forth, okay, at a certain frequency or a certain amount of hertz to that. And what happens is, whatever our load is or our resistance is, we have electricity get pushed this way, then that way, then this way, then that way, then this way, then that way, this way, then that way, and that alternating current has a constant electron flow across the resistor. Okay, so that's what we call AC current. Now, AC current in our country oscillates at 60 hertz. Okay, most of Europe runs at about 50 hertz. Okay, there are places in the world that run as low as 25 hertz. Okay, now in this idea, this different pulsing that they use, it's just every country, as electricity was developed in the late 1800s, early 1900s, kind of adopted their own standard. That's why when you go other places, you sometimes need to have different plugs and you have special equipment. You can't bring maybe your hair dryer to go to, Germany, that kind of stuff, because if it's the wrong amount of hertz, you actually can damage or burn up your devices based off of the different alternating current and that kind of thing. So there's ways to convert that. People buy converters, that kind of stuff. Okay. Now, the person who marketed this idea of AC, his name was Westinghouse. Okay, Tesla was a person who did all the research. He was a scientist, but Westinghouse was the businessman behind it. Okay, as we look at this. Now, in terms of our currents, direct current really isn't a slide in here because direct current is pretty straightforward. It's just a one-way street. Okay, you push current directly in one direction, and the current flows over top of everything. What we've been looking at so far in terms of circuits and stuff, it's all been direct current. Okay, just moving in one direction in terms of that current. Now, in our world today, AC current dominates the power grid. However, we do use a lot of DC current. Okay, in the late 1800s, it actually was a pretty big battle. It was a political battle. It was a commerce battle. It was a money thing, and it happened between Westinghouse, who was a promoter, and Tesla, the scientist, and Edison. Okay, now Edison wanted DC current. Westinghouse, Tesla wanted AC current, and they both were, developing the technology. They were trying to sell it to cities and countries and the government, and trying to sell it to businesses to basically win the battle between which type of current were we going to use to power our world. Okay, Edison tended to fight kind of dirty. Okay, he set up kind of weird things, like he would actually set up a public display using AC current, and he literally killed an elephant in a public display. The elephant was going to be put down anyway because it was too mean and it was being aggressive. Came from some sort of circus, so they had to put it down anyway. So he basically got the rights to kill this thing and in public to show how dangerous AC current was. Okay. He also invented the first, he didn't invent, his employees invented the first electric chair, and he used AC current to show how dangerous AC current is. We use it to kill people in prisons and that kind of stuff. So he fought kind of dirty. Now, the big thing is, why did we end up with more of an AC current world versus DC? It came down to Niagara Falls. So when Niagara Falls was built, okay, they were going to use it to power New York and the region and the area, and the contract was won by Westinghouse and Tesla. So they chose to use AC current to do that. Okay, and there's actually a very good reason for that. It wasn't just because they liked them better or they didn't like Edison, that kind of stuff. It actually was a good decision at the time to use AC over DC in terms of starting to build our electric grid. Okay, so let's talk a little bit more about AC current. Okay, AC current is always changing direction. So here's some advantages by doing that. Okay, you can really easily vary the voltage. Okay, so transformers, and we're not going to get into what transformers, how they all work, but basically a transformer is a device that allows you to change your voltage um, as it works through different areas. Okay, so power companies send power out, and then in different spots they actually can transform that. So if you ever looked on top of those power lines, you see those big, like kind of gray cylinder looking things. Those are transformers. Okay, and a transformer, it can step down your voltage or step up your voltage depending on how far you need to push the current and how much you're going to use that current. Okay, the biggest thing is it can be sent over long distances. Okay, so that's kind of our key thing right here. So I would circle that guy right there. They could build one power plant and supply more power to a larger area than DC current can. Okay, it is more efficient. It tends to be more reliable in terms of a big grid system. Okay, and it does take some development, but once it is developed, it is actually cheaper to produce. So if you think about it, these are all really good things in terms of like getting a whole grid of electricity up in your country or a town or a state. Okay, now it is more dangerous. Okay, because it's alternating current, it is definitely a more dangerous way of powering things because you're constantly pushing electrons back and forth across something. So you actually, anytime you switch directions, that creates more danger to it. Okay, the technology was harder to develop. Now, once it was developed, it was easier, but it actually took them more work to figure it out. Okay, it came later because of the initial technology was harder to develop. Okay, and then the one thing, which wasn't a big issue necessarily back in the late 1800s and 1900s, it doesn't really work to charge batteries. Okay, so that becomes an issue, especially in our world now, where a lot of things are utilizing battery technology. Okay, so this is a major disadvantage to AC current that we are now kind of dealing with as part of our society now. Now, direct current with that flowing in one direction, okay, some advantages it has if you're going to use lighting and simple motors, okay, especially back in those days, it was actually worked better or nice to power them up, made it more consistent in terms of that power. Working with batteries is huge, simple design, and it's less dangerous, okay. Now, what makes it hard is it's hard to modify the voltage. So once you have the voltage set, you got to kind of stick with it, okay? And the biggest one are these two here, which then leads into this one actually also. It's really hard to distribute DC current over long distances, okay? Because you're trying to push electrons all in the same direction all the time, you build up more heat, and it becomes inefficient. And as a result, in rural areas where you may have one power plant that maybe powers an entire, let's say, the whole western side of Iowa, okay? It's just too inefficient. You couldn't get electricity to rural areas. Now, this is especially thinking about 1800s and 1900s. You know, to get electricity out into our rural areas, in our mountainous regions, those kind of things, there was no way that they could have used DC current, okay? And that's what Niagara Falls came down to also, is that Niagara Falls, they wanted to build one big power plant using the falls to generate electricity, and they wanted to distribute that as far out as they possibly could. So a single plant at a single location, the only thing they could really use is AC current to make that work. Okay, for DC current to work to power a large area, you would need to have multiple power plants, all spaced, a mile, 2 miles apart, and so forth, like that, to power smaller areas. Okay. Now, we have since developed some technology that allows DC current to be pushed out in longer distances, but it's still pretty low efficiency, so it's still not the preferred way, even in our world today, to send out electricity through our world. Okay. However, we do use both types of current. Okay. So we're using DC and AC in our world, and you guys may or may not even know it because we're pretty clever in how we work with that. Okay. So first of all, what uses DC current? Okay. So you may be thinking, well, it's good at charging batteries, so probably anything that uses batteries, and you're absolutely right. So any device that you plug a battery into, whether it be a kid's toy, a flashlight, your cell phone, anything that's battery powered, cars, battery powered cars, all run on DC current. Okay. In fact, your car engine, it's even a gas powered engine, runs on DC current too, because it runs off that battery inside your car. Okay. So anything like that is DC current. Okay. Now, what you might not realize is anything that you have to plug into the wall and you have those big plugs, okay? So whether it be like your hair dryer, or whether it be like a plug for a TV, or maybe like an Xbox with that, and it has a big plug on it. If you have a big plug on it, that plug is called a transformer. And what that plug does, it actually transforms the AC current that's coming to that outlet. So every house is wired AC. So all your outlets in your house are alternating current. But things that need DC current, like plasma TVs, flat screen TVs, all the chargers for all your cell phone type of stuff, they need a way to convert that from AC, which comes into your house, to DC. And that's what that big plug does. It's also why that big plug, if you feel it, if you've been charging your phone or something, you feel that, it actually warms up, because the process of converting from AC to DC does lose some energy there. So we actually have some inefficiencies there, and we lose it as heat. So that transformer actually does build up heat over time. Okay, so anything battery powered, even things that you may not have a large plug, like for example, flat screen TVs now. They don't have the very large plug. You plug them in. They're nice, sleek design. They can stick against the wall. What you don't know is inside the actual TV itself, they have the transformer. So they sometimes put the transformer in the device and kind of hide it that way too. Okay, but there are a lot of things that run on DC current. Now, what uses AC current? Well, first of all, your whole house is wired AC. Any outlet that you have is AC. Okay, so any small appliances we use, any corded power tools that we use, all your household items we use, those are all AC current type of things. Okay, it's just kind of get an idea for what is used and what isn't. Actually, one of the newest things we're seeing in houses now is outlets that have both a traditional outlet on them, and they also have a couple of USB ports in it. So that outlet itself is a transformer. So AC current comes into it, you plug in your stuff to run it, and then the outlet itself actually has a small transformer, then takes some of that power, transforms it to DC current, so you can plug a USB device in it also, and run that way too. Okay, so that's kind of how we use it in our world. We use it for two different things. AC is our power grid. It's what's in our house. DC is anything battery powered or anything that gets charged. Okay. Now, that kind of ends that little video lesson, guys. And we will talk about resistance next time. Thank you.